All right, guys, today we're going to talk about something called the dot product. All right, what does the word product mean? If you're finding the product between two numbers, what is that? You're going to multiply, okay? So this is going to involve some multiplication. Dot product is this formula right here. All right, you guys aren't going to get these formulas because they're not very helpful, honestly. But I want you guys to understand what a dot product is, how it's notated, that sort of a thing. If you notice here, we know that these are two vectors. Why do you know that these are two vectors, U and V? How can you tell by looking at them? They're lowercase and they're bold, right? Now this right here denotes dot product. In most cases, 90% of the time, you will have directions that say find the dot product. So you're not wondering, is this multiplication? But it is a raised dot that's similar to multiplication, but it's bolded as well. This is, hey, find the dot product. That doesn't say U times V. If they want you to multiply two vectors together, they would make it like this, and they'd be bold, right? So this is called the dot product. And the way that you find the dot product, and I've said this a lot last couple days when we talked about component form, when we found terminal minus initial, I said first with first, second with second. Same concept. You're going to have two vectors. You're going to multiply the first part with the first part, and you're going to add it to the multiplied product of second times second. When you have a dot product, it is a singular value. Right? When we were just adding and subtracting and multiplying vectors, we came out with an answer that was a vector, like something comma something, like that, right? When you have a dot product, you're going to have one singular value. Do you guys understand what I mean by that? We're going to do some problems. You're going to be like, this is so easy. Again, there's some vector operations that you guys are all familiar with from all of the other math classes that you take in when we talk about combining like terms and X and Y and all that stuff. When you multiply vectors, when you add them together, all of our same mathematical rules apply. If you multiply a vector by 0, it's 0. V times V is V squared. That's the magnitude, all that sort of thing. If I multiply U times V plus U, like here, if I distribute here, this is the same thing as multiplying these two plus these two. That sort of, those properties all apply. So here's a question that it'll say find the dot product, okay? So when you find the dot product, you're not multiplying the two vectors together. You're multiplying first times first. So I'm going to write it out so you guys can see it. God bless you. 4 times 2 plus 5 times 3. So when you simplify this, what is 4 times 2? 8, good. Plus 5 times 3 is 15. And what is 15 plus 8? What is it? Plus. 23. So your dot product of those two vectors is 23. It's a singular value. So if you're finding the dot product, guys, you take the first times the first plus the second times the second. Let's do the second one. First times the first. What's 2 times 1? 2 times 1 is 2 plus the second times the second. So I have -1 times 2. So I have 2 plus a -2. What does that give me? 0. Do you think there's something special when the dot product is 0? Probably. Yeah, we'll talk about it in 1 second. And then let's look at the last one. Dot product. 0 times 4. So it's 0 times 4 plus 3 times -2. 3 times -2. Do you guys see how I'm writing out my work? This is not math that is just so hard for you guys to do, but I need to see the steps on how you get your answer. So you're showing me the process to find the dot product. This is showing your work. 0 times 4 is 0, plus 3 times -2 is -6. So your dot product here is -6. Okay, now we're going to come back to B in a second, but I want to introduce you to a new word. All right, when the dot product equals 0, the vectors are orthogonal. Anybody ever heard that word before? Leland, you might have in physics. But when the dot product equals 0, vectors are said to be orthogonal. You all know what that means? That means they meet at a 90-degree angle. What's another way that we can say when something meets at a 90-degree angle? What's that word with a P? Perpendicular, yep. In geometry, perpendicular means 90. In physics and vectors, orthogonal means, God bless you, meets at a 90. God bless you. So when the dot product is 0, your vectors are orthogonal, meaning if you graph them, they would meet at a 90-degree angle. So if you were going to prove if something was orthogonal or not, you would find the dot product, and if it's 0, then you know, oh, these meet at a 90-degree angle. They're perpendicular. So you already know what that means. It's just a different word. All right, scooting along. Here's my vectors. I have u, v, and w. It says use the vectors and properties of the dot product to find. All right, we're going to do all 3 of these. So let's look at A. A says the dot product of u and v, and then I'm going to times it by w, right? So the first thing we're going to do is write out our problem. I have u, which is -1, 3. Dot product, v is 2, -4. And then when I'm done with that, whoops, I'm going to multiply by what? By what? W? 1, -2. So let's find the dot product first. Dot product is first times first, so -1 times 2 plus second times second, yeah? You guys with me? Okay, so what's -1 times 2? -2 plus -12. What does that give me? -14. So what am I doing with -14, guys? Now I'm now doing what with it? God bless you. I'm distributing into vector W. So I say -14 times 1 is -14. And -14 times -2 is 28. And there is your answer. That's the dot product of UV times vector W. Remember, dot product is going to give you a singular number, not a vector. Stop me, guys, if you have questions as we go through this. Let's look at B. What does B ask us to do? U dot product to V. Okay, so what should we do first, you think? You should multiply. You should multiply that 2. That 2 is times vector V. So you have U, which is -1, 3. Then I'm going to find the dot product of 2 times vector V, which is 2, -4. Do you guys see the importance of writing out the vectors? Put it right in front of you so you can see exactly what you're doing. You don't want to keep going back and forth, looking up here, down there, up here, down there. You want to have it all right in front of you so you can just go ahead and find your answer. So I'm going to keep -1, 3 out here in front. And I'm going to distribute that 2 first. So 2 times 2 gives me 4. And 2 times -4 gives me -8. Now we're going to find the dot product. It told us to find the dot product. I will tell you, find the dot product. But when you guys do that, should your answer be in vector form or is it one singular answer? One singular answer. Good. So it's first times first. So -1 times 4 plus second times second. So 3 times -8. What's -1 times 4? -4 plus what's 3 times -8? -24. So what is my answer? -28. Are these two vectors orthogonal? No. What would my answer to my dot product be if they were orthogonal? It would be 0. Good. All right. Yeah. Say it one more time.
Like in -14, 28, they're in a vector form, but then...
Because of the operation, because we have to do parentheses first. So this told me to find the dot product first, and then multiply it by vector W. This one said multiply here first, then find the dot product. Good question. All right, what is, excuse me, what is letter C asking you to do? The magnitude. All right, remind me again what magnitude is. It's the distance, it's the length. But I don't have 2 points given. I have just a vector. So what do I do with the vector that they gave me? I have vector -1, 3. How do I find the magnitude when I have just one vector? You square. Good. Put underneath the square root. You square the first part, v1, plus you square the second part, which is v2. Because that's already your x's combined in that first v1, and your y's combined in the second one. So you have -1 squared is 1, plus 3 squared is 9, the square root of 10. You're going to leave your answers, guys, in radical form. If it says exact, and it'll say exact, you have to find the radical, not a decimal equivalent. If you can break down the radical, you need to do that. In this case, it doesn't. All right? Just a matter of practice. Just a matter of practice. Scooting along. All right, the angle between two non-zero vectors is an angle, look, between 0 and 180. Your angle can be found using the dot product and dividing by magnitudes. I'm going to show you an example here. This is just a picture of what you're finding. We're going to find the angle in the middle of two vectors. If the dot product was 0, what would the angle between the two vectors be? 90. Good. This is not going to be the case here. It's going to be something between 0 and 180, but it's not going to be 90 because the dot product is not going to be 0. Here is the formula. Now, before you guys go getting like, what? First of all, what trig function do we use in our calculator? Cosine. What is this part? It's the dot product. Good. And what is this part down here? The magnitude. It's not hard, guys. All you're going to do is find the dot product in the numerator of whatever they give you, the two vectors, and then you multiply the magnitudes together in the denominator. This is not a formula that you guys should be, oh my gosh, I can't remember. It's dot product on top, magnitude on the bottom. Very simple. All right, so you're going to use your calculators. You got to use your calculator for this. It says find the angle between. So if I'm going to find the angle between, I'm finding the cosine of the angle. So what am I going to have to do at the very end? Yep, you're going to hit second cosine. But it's the dot product in the numerator and the magnitude in the denominator. So let's write it all out. Dot product. How do we find dot product again? It's first times first. So 4 times 3 plus second times second. So 3 times 5. Everybody with me? Yep, okay. Then you find the magnitude of both of these. So I'm just going to go here. We're going to multiply them together. So I'm going to say 4 squared plus 3 squared. That's my U magnitude. And then here I have 3 squared plus 5 squared. All right, I need to see that you understand. Okay, I determined the numerator is the dot product. The denominator is multiplied version of both magnitudes. Some of you, hang on one sec, some of you are going to want to do everything in your calculator. I do not think that is a good idea at this point because there's a lot of parentheses and stuff that you have to enter. I would simplify a little bit before you throw in your calculator. Hannah?
Why wouldn't you put it under 1 like so?
Because it's two different magnitudes. You're finding the magnitude of U and the magnitude of V. And then you're going to multiply them together. So we still have the cosine. Let's simplify. What's the numerator? What's 4 times 3? 12. And then what's 3 times 5? 15. So what's 12 plus 15? 27. Okay, so 27. Perfect. Now I'm just going to simplify my radicals to one number. 4 squared is 16. 3 squared is 9. What's 16 plus 9? 25. Okay. And then over here, same thing. 3 squared is 9. 5 squared is 25. What's 9 plus 25? Square root of 34. Now, if you want to go ahead and simplify square root of 25 as 5, you can do that. If you want to go ahead and multiply the square root of 25 times the square root of 34 and get a bigger radical, you can do that. That's totally fine. Do you guys understand? Or you can put it in your calculator just like this. I would suggest probably, since this does simplify a little bit, I would say 27 over 5 root 34. Just because it does simplify. Now, this is where it can get a little tricky. Some of you, everybody's calculator is a little different. If you have an N over D button, like Kristen has that calculator, it's got N over D, it's easy. You see that and then just stick it in. But you need to have 27 in your numerator divided by 5 times 34 in your denominator and give me at least 4 decimal places. .8528. How many people agree? Anybody? All right, I got, and I think some of you would agree with me. Hold on. No worries, that's why we're practicing. At 0.92609. Okay, so guys, is this the measure of the angle? Is your angle 0.93 degrees? No, this is the cosine of the angle. So this is where we hit second cosine, second answer. Right, so you're going to find, but some of you on your quiz, you rounded to 2 decimal places at this point, and then your angle measures were way off. They were like 3 and 4 degrees off. If you're going to round, you have to then give at least 4 decimal places. Just because it says it for your answer, round to the nearest tenth, that doesn't mean throughout your problem you round to the tenth. You need to hit second cosine, second answer, and you got how many degrees? Theta is 22.16 degrees. All right, we'll just keep it to the nearest degree because it doesn't say, does it? Yeah. So the hardest part of this problem actually is entering it in your calculator. A lot of people, they want to start from right here and be like, I can just put this whole thing in and you get some really crazy answers. I would not do that. I would just simplify, simplify, simplify until you get something that's a little more manageable to work with. Does that make sense? All right. Now, we've kind of already talked about this, so this will go quickly. The terms orthogonal and perpendicular mean essentially the same thing. It means that they meet at right angles. So how do you know if vectors are orthogonal? You might have a question that says, are these orthogonal, yes or no? The answer that I'm looking for is not yeah or no. It's the proof behind it. It's showing me why. And the reason that vectors are orthogonal is when their dot product is 0. All right, do you guys understand that? So if you are asked to prove that something is or isn't orthogonal, the dot product has to be 0. You have to show it. So are these vectors orthogonal? The answer yes or no. Not really what I'm looking for. I'm looking for the math behind it. Similar to, remember we did odd, even, neither? So if you're like, even, no, you have to show me why. Yeah.
So this isn't like what we just did about finding angles.
No, this is just, are they orthogonal or not? Yep. Just it's the different types of questions. So are the vectors orthogonal? That means dot product equals 0, if they are. So let's find the dot product. I'm going to say first times first, 2 times 6, plus second times second. Now, I cannot impress upon you guys enough. I know that every single person in here could do this in their head. They could go 2 times 6 is 12, plus -3 and 4 is -12. Oh, yeah, it's 0. Showing your work at the top of your test, it's going to say in big bold letters, show all work to receive full credit. No work equals no credit. If you guys don't show the work to prove that something is the correct answer, you are not getting credit. If you tell me I did it in my head, okay, fine, then you're sacrificing points. Make sure that you are not taking shortcuts. 2 times 6 is 12. Plus -3 and 4 is -12. So you found here that your dot product was what? 0. Since the dot product is 0, then your answer would be yes. These are orthogonal. If your dot product was anything else but 0, your answer would be what? No. But this is what I'm looking for. You have to support your answer with math. Comprende? Okay. Good job. All right, we're almost done. A little more about orthogonality. I think I just made that word up. 2 vectors that are perpendicular are vectors that meet at right angles are orthogonal, right? We've been talking about that. They're orthogonal if and only if the result of their dot product is 0. Again, same thing we just talked about. I just want you to see it. Now, two vectors are parallel. What does parallel mean? Show me with the arms what parallel is. Yep. Right? They don't have to be, whoops, bad color choice. They don't have to be straight up and down, but they're a directed line segment that do what? Never does what? Never touches. So how can you mathematically prove that vectors are parallel? Well, what is this showing you? You take your u vector. You take the first one, whatever it is. You put u over v equals u over v. If it's a true statement, then they're parallel. If it's not true, then they're not. And with numbers, you'll see this is a lot easier. Determine if these are parallel, orthogonal, or neither. Okay, so this is how you would do a problem like this. First of all, I don't like when it's written like this. How can I rewrite this so the vectors are real easy to see? 2, comma, negative 2. Perfect. And then what's v? Negative 1, comma, negative 1. Now, to prove if they're parallel, to prove if they're orthogonal or neither. All right, let's check to see if these are parallel. If they're parallel, that last slide told us we take the first u, or the first part of the first vector, and we put it over the first part of the second vector. Does that equal the second part over the second part? Simplify this. What is 2 divided by negative 1? It's what kind of 2? It's negative 2. What's negative 2 divided by negative 1? 2. Does negative 2 equal positive 2? No. So are these parallel? No, they're not parallel. That's how you just prove that. So let's check to see if they're orthogonal. Well, remind me again, how do we find orthogonal? Tell me again, Mike. Mikey, good. Dot product. So first times first, 2 times negative 1 plus negative 2 times negative 1. Well, what's 2 times negative 1? Negative 2. Plus, what's negative 2 times negative 1? 2. What's negative 2 plus 2? What did we just prove here? They are orthogonal. So if two vectors are parallel, you would put the first part of the vector over the second part of the first part of the second vector. And then you take the second part of vector 1 over the second part of vector 2 and simplify the fraction. If it doesn't simplify to a whole number, that's fine. Just simplify it as much as you can. And then you guys will be like, oh, good. Okay, they are great. If they're not equal, then they're not. Questions? All right, this was a long one today. I understand that. I talked a lot, but that's okay. We got all of it done. So you guys have a web assign. I'm going to check the date, make sure I have it due. But tomorrow I'm going to give back your quizzes. You can work on WebAssign tomorrow. I can answer questions, but try to look at it tonight to see, if you guys can get the hang of it. And then I'll also give you the test review that we can start working on. Sound good? Okay.